This presentation is the second of two presentations on understanding, calculating, and interpreting an independent samples t-test. To recall, the independent samples t-test is a versatile test that works when we have two subsets of a larger sample of data and we want to test whether or not there are significant differences between the samples. We took our first step at understanding the formula in the first presentation. As a reminder, here is the formula for the independent samples t-test. Let's take an actual example from our discussion of Idaho regionalism. Here is the example. This example takes data from the three regions of Idaho on the mean teen pregnancy rate from 1997. We have in front of us the mean value for the teen pregnancy rate in the North region, the Southwest region, and the Southeast region. The rate is per 1,000 teen females. It looks like the rate is substantially higher in the North and the Southwest than in the Southeast. But we can only know if it is a statistically significant difference when we calculate the formula. So let's get started. The table gives us all the information we need to complete the calculation. We need to know the standard deviation for the regions, as well as the number of cases or counties in each region. We just simply plug the information into the formula, follow the steps, and get results. Here's a suggestion. You should take a screen capture of the formula and a screen capture of the data table and have them open while you're watching this podcast to follow which information gets placed into which part of the formula. Let's compare the North region to the Southwest region. In this comparison, we will call the North region sub 1 and the Southwest region sub 2. Thus, our first step is to get the information into the right parts of the formula. The formula has all the correct information in it. The mean teen pregnancy rate values are 31.35 for the North and 29.21 for the Southwest. The standard deviation for the North is 11.48, and for the Southwest it is 14.41. As a note, the Southwest region's higher standard deviation tells us that there is more variation in the mean teen pregnancy rate in the 18 Southwest County regions in Idaho than there is in the 10 North region counties. Finally, n equals 10 for the North and 18 for the Southwest. Our next step is to subtract the mean values for the numerator, resulting in 2.14. We will round to 2 decimal places with each calculation. We then square the values for the standard deviations. The square of 11.48 is 131.79, and the square for 14.41 is 207.65. We then, on the lower left part of the denominator, add the two case totals for our independent samples and subtract 2 from this result. So 10 plus 18 equals 28, minus 2 equals 26. On the lower right of the denominator, we add the two sample totals, 10 to 18 to get 28, and multiply the two sample totals 10 times 18 to get 180. The third step is to focus on the denominator. On the lower left side, we start by multiplying the number of cases in each independent sample by the squared standard deviation for each independent sample. 10 times 131.79 equals 1317.9, and 18 times 207.65 equals 3737.7. On the lower right side, 28 divided by 180 equals 0.16. Our fourth step again takes us to the denominator. On the lower left, 1317.9 multiplied by 3737.7 equals 5055.6. On the lower right, the square root of 0.16 equals 0.4. Our fifth step is again concentrating on the denominator. On the lower left, 5055.6 divided by 26 equals 194.45. Our sixth step nearly releases us from exclusively concentrating on the denominator. The square root of 194.45 is 13.94. Remember, we are taking all calculations to 2 decimal places. Our seventh step is the final one that focuses on the denominator. The result of multiplying 13.94 by 0.4 is 5.58. Our eighth and final step is to divide the denominator of 5.58 by the numerator that we calculated many steps ago of 2.14. The result is 0.38, and this is the result of the independent samples t-test. Way to go in sticking with this. Now, we need to know how to interpret this result. We turn to page 146 of the Pollock 1 textbook, the student's t-distribution, in order to find the correct critical value that we will use to accept or reject the null hypothesis. Thus, we need to write the null and alternative hypotheses. The null hypothesis is that there is no statistically significant difference between the north and southwest regions in mean teen pregnancy rate. The alternative hypothesis is that there is a statistically significant difference between the north and southwest regions in mean teen pregnancy rates. To use the table on page 146 of Pollock 1 correctly, we need to know the degrees of freedom for our problem. The degrees of freedom is given by the bottom left portion of the denominator for the independent samples t-test formula. N sub 1 plus N sub 2 minus 2. We are accounting for the fact that we have 2 independent samples and that their size determines the degrees of freedom. For our problem, 10 plus 18 minus 2 equals 26. We find the row of information in the table that corresponds to degrees of freedom equaling 26. We then move our attention to the column headed by 0.025 area under the curve. We're using the absolute value of the calculation so that the result is always a positive number. Once we're there, we see that the critical value is equal to 2.056. Now recall the rule for accepting or rejecting the null hypothesis. If the absolute value of our calculation is greater than or equal to the critical value, we reject the null hypothesis. If the absolute value of our calculation is less than the critical value, then we accept the null hypothesis. Since 0.38 is less than 2.056, we accept the null hypothesis. If the absolute value of our calculation is less than the critical value, then we accept the null hypothesis. There is no statistically significant difference in mean values for the teen pregnancy rate in the north region of Idaho compared to the southwest region of Idaho. You can practice your independent samples t-test calculations by comparing the north region to the southeast region too. Since we observe that the difference between the 2 regions on mean teen pregnancy rate is pretty large, 15.06, we may guess that there is a statistically significant difference between the 2 regions. But the proof's in the pudding. We need to calculate the test result to see if we reject the null hypothesis. Give the calculation a try. We'll start by putting the numbers in the right places in the formula. Now do the calculation on your own. You should calculate the test result to be 3.51. Compare that to the critical value for the North region, Southeast region comparison of 2.064. Do you reject or accept the null hypothesis? This time you reject the null hypothesis. There is a statistically significant difference in the mean teen pregnancy rate between the North and the Southeast regions of Idaho. Why is this the case? We can conjecture that the cultures of the two regions are different, based on settlement patterns. The Southeast region was largely settled by Mormon pioneers, while the North region was largely settled by pioneers from California, Montana, and Washington State, who do not have the same religious tradition. There are very few people of the Mormon faith in the North region. The more traditional culture of the Southeast may be an explanatory factor in our independent samples t-test result. It's quite possible that these cultural differences filter their way down the mean teen pregnancy rate. You can practice more on comparing the Southwest to the Southeast region as well. I've given you the numbers to plug into the formula to practice calculating the independent samples t-test. I'll provide the answers on the next slide. The independent samples t-test calculated result is 2.90. The critical value for degrees of freedom equals 32 is 2.042. Since the calculated result is larger than the critical value, we make the decision to reject the null hypothesis. The Southwest region has a statistically significant higher mean teen pregnancy rate than does the Southeast region. Again, you might consider how different southeastern Idaho is from the rest of the state in terms of its religious demographic, which may reflect a different cultural dynamic that expresses itself in statistics such as the mean teen pregnancy rate. This concludes our discussion of the independent samples t-test.